In this video, one will be able to understand the application of Kirchhoff voltage law, or with the help of mesh current analysis, how can we find the unknowns for a given question. It might be either voltage, current, resistance, power, etc. So here we have considered only the active elements being voltage source only as per the syllabus. So I am Mohan B.S. working as Assistant Professor, Department of EEE, SJBI. So before we go further, you have to understand how do we mark the polarity across any passive element, and here being only resistance, as you're dealing with DC circuits. So there are two cases of assumption. Let us assume case A as shown in figure A. I have a resistance, two ends have been marked as A and B, as you can observe. If the current is assumed is entering at point A and leaving at point B, so where the current enters, one has to mark positive, and where the current is leaving, it would be negative. So assume the current flow as shown in figure A. That side of the resistance where the current hits or meets, that is where the current enters the passive element, is marked as positive and the other side as negative. Remember, this has to be done for passive elements which are nothing but R, L and C, and not for any active elements. Similarly, in figure B, if it is assumed the current being entered through point B, then at point B it is marked positive and at point A it is marked negative. That side of the resistance where the current meets or hits the passive element is marked positive, and the other side is negative for figure B also. So understanding this, we'll see how do we solve problems. Now, so we'll be having either two or three simultaneous equations to be solved to find the unknowns, that is the currents, is in Kirchhoff voltage law. So it's better you can scan the QR code for the video where we have seen, where we have recorded how do we solve the simultaneous equation with two or three unknowns through a calculator, not by the conventional method that we have done in a 10th of PUC, by graphical method, cross multiplication, elimination or substitution method. Just by calculator one can solve, and that part has been skipped in this video. You can refer a video that has been already pre-recorded. Scan the code to go to the video link. So what is a mesh? So mesh is called the simplest form of loop. It's also a subset of loop. So let's see the definitions and example through this circuit. So I have marked the points or nodes as A, B, C, D, E and F. So what are nodes? End of each element is defined as a node. So 28 volts has two ends, that is A and F. 4 ohms has two ends, that is A and B. 1 ohm has two ends, that is B and C. 7 volt has two ends, that is C and D. Okay, so D, E and F, all three are actually at same potential. Whether we'll see this concept under KCL. So as of now you can neglect that. So this is one loop. Loop 1 starts from A, B, C, D, E, F and again ends at A also. So loop can also be said the starting and end points are same. This is loop 2, where is starting from A, then B, E, F again at A, starting and end are same. Then loop 3 starts from point B and again ends at point B. So B, C, D, E and B. So these are the three loops. However, these two can be, loop 2 and loop 3 can be told as mesh. The simplest form of loop is called as mesh, or loop does not exist within itself. So you can see A, B, C, D, that is loop 1 has two loops, that is loop 2 and loop 3. Whereas loop 2 and loop 3 or mesh 2 and mesh 3 does not have a loop within itself. Thus we can call those two as meshes and not loop. So loop can have subsets of loop, but meshes will not have its subset. So a loop in any closed path through a circuit where no node is encountered more than once. Loop is a superset of meshes. Start and end points are same. Mesh is a closed path in a circuit that contains no other paths. Mesh does not have any loop within it. They are also called fundamental loop. All meshes are loop, but not the true vice versa. So I hope now you have understood what is a loop, what is a mesh. Now, number of meshes in a given circuit. How can you find number of meshes in a given circuit? So here I'll say I have 2 meshes. So what you can do to analyze is just assume this as your single line diagram for your house. Okay, where all are connected. The elements are X, Y, Z parameters. So at the top, if you observe, how many areas can you observe, or how many rooms can you observe? So here you can say I have 2. Thus I'll say I have 2 meshes. So I restrict my explanation with respect to only voltage sources. And when we have a current source, how do we solve this? Not in the purview of the syllabus. So let's see step by step the solution for a given problem. First, the current has to be assumed or not. Now here, this is a given question where they have not given any mesh currents. Thus we have to assume the mesh currents. So how do we assume the mesh current? So we assume the mesh current in clockwise direction. So I have simply or vaguely assumed the first mesh as I1, the second mesh as I2. So you can assume instead of I1, you can assume as IA or I2 or I3, anything. So here I have assumed as I1 and I2 as my 2 meshes. Next, what you have to do? Mark the polarity across all passive elements. So what are passive elements? That is all that actually consume or stores energy. That is R, L and C. Now, so here I want you to observe the flow of current. The red one is actually I1 and the yellow one is actually I2. So I hope you have observed that I1 flows through 4, 2 and 28 in clockwise direction. The yellow is nothing but I2 which flows through 1, 7 and 2 in clockwise direction. And also I hope you have observed that both currents are traveling through one resistance, that is 2 ohms, in opposite direction. I repeat, I1 is traveling down through 2 ohms and I2 is traveling upwards through 2 ohms. I hope you have observed that in the animation. Now let's mark the polarity as we have discussed in this video earlier. So wherever current hits, we're marking positive. So here I'll have positive, here I'll have positive, and here I'll have positive. So for 2 ohm towards the left, I have positive because of I1. And 2 ohm at the bottom towards the right side in the mesh 2, I have positive at the bottom because current is traveling, I2 current is traveling in upward direction. Now neglect the unknowns and apply KVL or mesh current analysis to find mesh currents. So the unknowns might be that you have been asked to find voltage or current or power associated with XYZ elements. So assume that nothing is there and then only you have to start solving. So that is what we have done from the scratch. Okay, so we'll see what was the actual question later. It might be to find voltage across 4 ohm, current through 2 ohms, or voltage across 1 ohm, or power associated with 28. So those questions you first initially neglect and blindly apply what we have done. That is step 1, assume the current, mark the polarities. Okay, and then we have to write the KVL equation. So Kirchhoff voltage law, sum of all the voltages or the voltage drops in a closed circuit is equal to the total voltage of an active element. Okay. So here we have 2 meshes. Though your R matrix will be 2 cross 2, I matrix will be 2 cross 1, and V matrix will be 2 cross 1. That is number of unknowns. That is I1 and I2 into 1 for current into 1 for voltage, and number of unknowns into number of unknowns is your matrix dimension for your R matrix. So dimension of R matrix is 1, 1, 1, 2, 2, 1 and 2, 2. So 1, 1. What does 1, 1 mean? So 1, 1 means here just a shortcut method to solve. However, in detail you'll be seeing in upcoming video. So 1, 1 means all the elements that are connected to mesh 1. So here in mesh 1 I have all the resistance which are connected, that is 4 and 2. Thus I'll say 6 ohm as 1, 1. Similarly 2, 2. All the resistances or passive elements that are connected in mesh 2, that is 1 and 2, which is nothing but 3 ohms. Now what is 1, 2? So 1, 2 and 2, 1 means which are between mesh 1 and mesh 2 for 1, 2. Between 2 and 1 is for 2 cross 1, 2, 1. It will be same as it is nothing but 2 ohms. But however, we write here minus 2. Why minus 2? You'll be hold on that doubt. Just keep your doubts aside for this. We'll be explaining it shortly. And what are the 2 currents? That is I1 and I2. And what are the 2 voltages? Now in first mesh, the current I1 hits negative. Thus we write here, I repeat, the current I1 hits negative of 28 volts. So we write here positive 28 volts. Why? We'll see it shortly. As I told, this is a shortcut. Next, current I2 hits positive of 7 and we write minus 7. Again, why? Please hold on to your nerves. We'll see see it shortly. And if your doubt is yes, will the mark be allotted if you write this equation? Yes, it will be allotted. Okay, the explanation for why we have got minus 2 for 1 comma 2 and 2 comma 1 and how we have got 28 and minus 7, we'll see it shortly. So now let us say after solving that matrix, and how do we solve that? How do we get I1 and I2? As I told, substitute that in your simultaneous equation, so in your calculators, and you can solve. As told earlier, please scan that code and see the video. How do we solve for the simultaneous equation? Now if the given question is VA, to solve for VA, so what you have to do, neglect VA, apply mesh current analysis or KVL to find I1 and I2. And now we'll see how do we solve for VA. Now by Ohm's law we know V is nothing but R into I. So VA is voltage drop across 4 ohms. And what current is flowing through VA or through 4 ohms? That is nothing but I1. And I1 hits which terminal of VA? Now please don't get confused. 4 ohms we have marked plus minus, and in the question also they have given plus minus. Okay, the next question that doubt will be clarified. So 4 ohms voltage polarity plus minus we have marked, VA plus minus is being given in the question. So current I1 hits positive of VA, thus it is positive. Now, so here you can see, to find VB, it's given in the question as minus and plus VB. Now here for VB, according to Ohm's law, it is R into I. R is 1 ohm and I is minus I2. How is it minus here? So current I2 that we have assumed hits negative of VB. That is why it is minus I2. Okay, now what exactly is this VA and VB? VA and VB are nothing but your voltmeters which are connected. But the actual drop is what we have marked. Okay, so in the question they have given us VB, and how do you solve? Write the voltage drop, that is write the value of voltage, that is 1, and see where the current hits for VB. For VB, the current that they have for the polarity that they have marked, the current I2 hits negative of VB, thus it is minus. So VB is nothing but minus of 1 into I2, and I2 is also 1, thus it is minus 1 volts. Next, let us say the question is asked to find IB as shown. So I will simply say IB is actually the current that is flowing through the branch 1 ohm and 7 volts. So that is as same as your current I2. So I2 also flows in the same direction through 1 ohm, and IB also is flowing through 1 ohm in the same direction. Thus IB is simply I2, which is 1 ampere. Now what about IC? Now here in this branch, as shown earlier, both I1 and I2 current are flowing. So I'll give you 4 options. I want you to think what would be the right answer. You can resume back shortly. So I hope you have done the exercise. You've got the right answer, and I would eliminate all the incorrect answers and show you the right answer, and then I would explain it. IC is simply I1 minus I2. How? IC is going down through 2 ohms. Now through that 2 ohms, we have 2 mesh currents, I1 and I2 also flowing. However, I1 is flowing down through 2 ohms. I1 is flowing right towards 4 ohms, down towards 4 ohms, left in the wire, and up through 28 volts. That is in clockwise direction. However, through 2 ohms, it is flowing downwards, and as it is in the same direction, it is taken positive. What about meshed current I2? Mesh current I2 is flowing right through VB, that is through 1 ohm, down through 7, and left through the wire, and upwards through 2 ohms. Thus I2 is traveling opposite to IC. We take it as negative. Now what about power? What is the power associated with 28 volts? The power formula is simply V into I. And in that bracket you have to fill the polarity. So let us see. The current, which current is flowing through 28 volts and what direction? The current that is flowing through 28 volt is simply I1 in upwards direction as shown. Okay. Now this current I1 current flowing through 28 volts hits negative terminal first. Thus we write 28 minus I1. That is 28 minus of 28 into I1. The equation would be minus of 28 into I1. The voltage is 28, we'll write 28. The current I is I1, we'll write I1. And the current I1, as it hits the negative of VA first, we write that as minus 28 into I1. So let us see for 7 volts. What is the power associated with 7 volts? The equation is same. For any active element, we use V into I formula, not I square into R or V square by R for any active element, that is voltage and current source. So the voltage is 7 and the current is I2 and it hits positive. Thus we write 7 plus I2, that is positive of 7 into I2. Now negative and positive, what does the power indicates? So positive power indicates that it is getting charged. It's a load. And negative power indicates it's a source. It is supplying, discharging. Okay. So in this video, we'll be discussing about the KVL equation. So initially you saw flow of current I1. Now this is the flow of current I2 alone. And now here you can see now both I1 and I2, they are flowing, and the current through 2 ohms is actually, it's subtraction of the currents I1 and it's a combination of current I1 and I2. So depending upon the direction, we can say it is either I1 minus I2 or I2 minus I1. So I hope you are clear with how do we mark the polarities. So mesh 1 equation, let me explain. It is 4I1. So always start applying KVL from left top corner of the mesh. Okay, for the first mesh, start from left top corner and travel in the direction of I1. So what do I see first polarity? I see 4. What is the voltage up across 4? 4 into I. Which current is flowing through 4? That is nothing but I1. So 4 into I1. And as I come down through in the path of I1, I see 2 polarities for 2 ohms, plus and minus, as marked there. So 2 is because of the plus is because of current I1 and minus is because of the current I2. Thus we have plus 2 I1 and minus 2 I2. And further as I go in the path of I1, we would see negative of 28. Thus write minus 28 equal to 0. Rearrange the terms by simplifying. We get 6I1 minus 2I2 is equal to 28. And now when you compare the matrix as shown in the previous few minutes back, 1 cross 1 we have got 6, that is 4 plus 2, and 1 common 2 we have got minus 2. So I hope now it is clear that how we have got minus. And the last column we have got for voltage 28, that is positive. I hope now it is clear by equation 1 that how we have got positive 28. So these are the equations or steps to be remembered. Based on equation 1 and 2, you can rewrite that in matrix form. What about mesh 2? Mesh 2 again start from left top corner and go in the path of I2. So what is the first element that you encounter? 1 ohms. What is its polarity? Positive. Thus we write plus 1 I2 plus 7, and then plus and minus is what I can see as encircled there for 2 ohms. Plus is because of I2 and minus is because of I1. Thus we write it as plus 2 I2 and minus 2 I1 equated to 0 as we have ended where we have started. Rearrange the term, and now this is important. In equation 1 we have started with I1 followed by I2 and then constant. Maintain the same order. So thus I would start from I1 followed by I2 and then constant. So because of that I write minus 2 I1 first, then I2, that is 2 I2 equal to minus 7. Now, so these are your constants that you, I hope you have seen the video with respect to how do you enter the data in calculator. With respect to that, for equation 1, A1, B1, C1 are respectively 6, minus 2 and 28. With respect to equation 2, my variables are the value for A2, B2, C2 are minus 2 and minus 7. So after substituting this and solving in calculator, we get the answer as I1 is 5 amp and I2 is 1 amp. So we have seen this in the last problem. So how do we solve for Vx? Pause the video you can write the answers. So Vx is simply I1 into 4, which is nothing but 20 volts. And what is Ix? Ix is simply nothing but I1, as it flows in the same direction of I1, thus it is 5 ampere. What about Vy? How do we write by Ohm's law? R into I. The value of R is 1 and the value of I is I2. However, the current I2 hits minus of Vy, that is why it is minus I2. So what about Iy? Iy is simply minus of I1, which is nothing but minus 5. Why is it minus? Because Iy is traveling through 4 ohms left. I1 is traveling right through 4 ohms. Thus, they are in opposite, we write negative. What about Iz? So Iz is simply minus of I2, which is nothing but minus 1. Now what about Ia? So I want you to pause the video and write the equation for Ia and resume back later. Ia, so I1 is flowing down through 2 ohms and I2 is traveling upwards through 2 ohms. Thus we write the equation for Ia as I1 minus I2, which is nothing but 5 minus 1, 4 ampere. Now what about the voltage up across this 2 ohms? For example, I'll call that as VA. Pause the video and think what could the equation be, and then resume back. So VA by Ohm's law, it is R into I. R is 2. What about I? So as discussed, we have two currents flowing through this 2 ohms. So which hits negative first? I repeat, which hits negative of VA first? There are two currents, I1 and I2. Out of these two currents, which current hits negative of VA first? That is I1. And I2 hits positive. Thus it is minus I2 plus I2 minus I1 plus I2 into 2, that is minus 8 volts. And it is obvious that VB will be plus 8 volts. The equation is I1 minus I2 into 2. So current I1 hits positive of VB first, current I2 hits negative of VB first. Thus it is I1 minus I2 into 2 volts. Thank you for watching the video. Please do subscribe the channel to enhance your knowledge further.